Thank you. Thank you, Dennis. Thanks for the wonderful introduction. Good afternoon, good evening, and good morning to all our audience and viewers from all over the world. Um, as Dennis said, my name is Jessica, and I will be um, doing my talk on Java versus Kotlin, the ultimate showdown of virtual threads and coroutines. So before we get to coroutines, we need to discuss some important aspects. So we're going to look at concurrency. So if you want to think of concurrency in a very simple idea, basically it's similar to having a group of people work on a project where each person is responsible for a different part of the project, but they can all work at the same time and not wait for the other to finish. So that's basically what concurrency is in the world of computers, but for programs. So you have like numerous tasks and all of them can be completed at once in any given order, and they don't have to wait for the other to finish to produce an end result. So that's what concurrency is. This allows the computer program to complete all its tasks because it's more efficient, and it's more efficient to have small tasks completed at once at the same time than do like one big task and then complete it and then do another big task, etc. So the there are like five things important about concurrency. Efficiency. So when tasks are run like in parallel or at the same time, the whole program works faster. It's like you can think of it as a well-coordinated team. That's why concurrency is so important. Responsiveness. So if you think of like something you have to do on your phone, like if you're downloading a big file, you still want to be able to move around to all the different apps. You still want to be interactive with the interface of the phone, and you still want them to be responsive. So it helps with that. It keeps all the other applications quick and responsive, even when lots of things are happening in the background. And use resource utilization. So it makes sure the computer parts are being well used. So without wasting time, every task is being done. Scalability. So as more like cores or CPUs are available, a concurrent system will take on more work, kind of like how you have a bigger team when you have more work. And real-time processing. So concurrency is really important for like any type of real-time processing. So if you think of anything that you could get real-time data from, so like a weather app digit or livestock trading, concurrency is the key to keeping them in action and responsive. So another key aspect with concurrency is asynchronous programming. So you get synchronous and asynchronous programming, but we'll be focusing on asynchronous programming. So it's a method of programming that allows like certain tasks to be run separate from the main application thread, or from the main application thread. So you have a thread that runs say, for example, you want to pull data from an API, you can run that on a different thread from the main application, basically. So this approach is used to prevent blocking. So like if you think of like waiting long operations, so like when you have to download files, it takes a very long time. So it helps with that. It's used to prevent blocking or waiting for long operations. So there are 6 like key aspects to asynchronous programming. So it's non-blocking, which means that tasks that take a long time to run don't stop other tasks from running. So it will still take a long time, but it doesn't stop everything else. So for example, if you click a button to download a large file, you can still scroll through the app, click buttons, do everything while the file is downloading. Efficiency, so allows the program to handle more tasks at once, while one part of the program will wait for the file to download, for example. Responsiveness, so applications stay responsive to user input. So when you use your phone doesn't freeze. So it can do all the different things and it doesn't freeze. The user interface doesn't freeze. Complexity, so this is something maybe you might need to like take care of. So the thing is, because the program is not going to flow in how you think of a program to flow, like from start to finish, you have to carefully plan what should happen to each task. because even though they can happen at like, say, all at the same time, some might need order, some might not need order. And you just need to keep that in mind when you work with asynchronous programming. But yeah, asynchronous programming is a key technique in achieving concurrency, and it allows programs to handle multiple tasks efficiently, especially in environments where like resources are limited or you're dealing with input and output operations. So now I'm going to introduce coroutines. Basically, a coroutine is a concurrency design pattern that you can use in Android to simplify code that executes asynchronously. So I'm going to give you an example of how I used coroutines in my project and where I used it and all the different parts of the code. Right now, let's just try and understand coroutines. So basics for coroutines is that you have coroutines in Kotlin for asynchronous code. And how it works is you can have a function, but you'll mark it with the word suspend. So basically, you are basically calling or called suspending functions which are usable within coroutines. So you'll see in my project what I did with my function that I suspended. And then you also have what you call coroutine builders. So it's how you launch a coroutine within your code. So you can use either launch or async. I use launch for mine, and you'll see that when I get to my project. And then I also use, so suspending functions can also, you can pause and you can resume them, and you can introduce delay, which is like non-blocking pauses. I didn't use that, unfortunately, but you can use them. And then you also have what you call a coroutine scope. So it just manages the coroutine life cycle. So a structured concurrency ensures proper management. So it's how you structure your coroutine or what you want it specifically to do for the application that you're working on. Cancellation. So you can automatically cancel them, but it propagates through the hierarchy. So you can have a parent coroutine, you can have a child coroutine. And I think if you delete the parent, then the child also disappears with that. And then you can also do exception handling. So basically what this means is like within your coroutine, you do like a try catch block for like exception handling coroutines. So you'll see exactly how I did mine for my application that I built. But basically, you use it to try for something that you want to succeed in your application, and you try to catch the failure in that application as well. And then you also have flow integration. So coroutines can work with flow for handling like asynchronous data streams. And flows are like composables, and they represent sequences of values over time. And integration. So Kotlin coroutines integrate well with libraries and frameworks, including Android Jetpack. So there's full support for coroutines in Kotlin, which is nice, and that's why I really like using them. So if you remember anything, remember the key features of a coroutine. They are lightweight. You can run many coroutines on a single thread, which supports suspension without blocking. So like you can have many different tasks, you can have many different coroutines within your coroutine and then run that on a single thread. It's memory efficient, so it suspends like memory over blocking while supporting concurrent operations. You have what you call you have fewer memory leaks. So basically, if you utilize a structured concurrency to run operations within a scope, very few memory leaks happen. It also has, like I mentioned before, built-in cancellation support. You can automatically cancel through content hierarchy and Jetpack integration. So yeah, many Jetpack libraries offer full content support. So now to get to some of the benefits of coroutines, there are a lot on the slide, but I'll mention like the most important ones are the ones that I think is really important. So you have improved responsiveness. So basically what this means is coroutines prevent blocking in the main thread. So that ensures that the application remains responsive to like any type of user interaction. So you can like go out of one app, go into another, and everything is still fine. So like long running operations like downloading a large file or doing a network request. So those can be like executed asynchronously, but without freezing the user interface. So without freezing the phone, basically. Number two, they are resource efficient. So they are designed to be lightweight. So by lightweight, they can run many concurrent tasks on a single thread. So it means they can do many tasks at once on a single thread. And this minimizes creating like overhead and managing threads. So if you can run many tasks on one thread, then you don't need to have many threads, which means you not using all of your resources, which is really nice. And then another great one is reduce context switching. So basically what happens is you can have what you call context switching between threads. But coroutines like mitigate this issue because you can run multiple tasks on a single thread, which means it reduces the need to context switch all the time. So instead of, how to say, you can run all the tasks that need to switch to each other at once on one thread instead of having many threads where they need to switch between the threads. Yeah, that's why it's also great, which increases performance. And then you also have faster startup times. So I was noticing this when I built my application. As soon as like I installed it, it just came to what I wanted it to be very, very fast. There was no delay time. It just went straight to the screen. So you have like faster launch app experiences. And I'll just do one more because there's a lot to explain, but I want to get to like my application so you can see how I used it. All of them are really important, but those are just a few that I think I would mention. So you also have scalability. So coroutines can scale well with increasing demands of your application. So that's quite nice. And asynchronous tasks can be managed efficiently, allowing your application to handle a higher workload while maintaining a good performance. So those are like just some of the few that I think are quite important. But in summary, coroutines provide significant performance benefits by optimizing resource utilization, reducing overhead, and allowing for efficiency. So it means you can run many concurrent tasks on within coroutines on a single thread, and they contribute to faster application responsiveness and improved overall performance, which makes it a very valuable tool for developers because you want high performance applications. So to get into my project, so basically for my project, I was retrieving data from an API, from the Simpsons API to be specific. So this is you can see on my slide, this is just a screenshot of what it looks like from my emulator. And it's just 13 quotes, but yeah, that's just what the UI looks like. But basically, I was pulling the data with retrofit to get data from the API. Yeah. So where did I use coroutines in my project? So in my specific project, I wanted the network request for the API to be run with coroutines. So that's where I used it. So I hope my screen is visible, but as you can see, I launched the function to get the quotes from the repository, the get quotes function, and then I launched the coroutine. So I used view model scope.launch I wanted to make an asynchronous network request to the API. So it just means that my network calls were made off the main thread. That's what it means, yeah. And then you can see I load, I start loading the loading state, and then I do like a try catch block at the bottom. So basically for error handling. So I have 3 state screens in this project. So I had loading, success, and error. So I started off with loading, I'm trying for success, and I'm catching the error. Error is basically like if there's no internet connection, it will tell you, look, the internet connection is very slow, and then it will go to the error state screen. So that's how I used coroutines for this specific project. So this is just the first part of the code that's for coroutines. And then for this part of my project, this is the snippet of code from the API service. So basically I imported retrofit. So the nice thing about retrofit and coroutines is that they integrate well with each other and work well together. And then I don't know if you can see, but at the bottom, after @get quotes count 13, I use the suspend function, which basically it just indicates that this function is a suspending function. So it can be paused, it can be resumed at a later time, but it's just particularly useful for a long running operation that would otherwise block on the main thread. So I'm running it off the main thread, and such as this could be like a network request. So I'm calling data from API, which involves some sort of network request. Yeah, so in summary, that's how I use coroutines in my project. So I use the coroutine to run the get quotes function to get the quotes from my API, and I use it to manage navigating the different screens with the try and catch block of code. Yeah, so that's how I use coroutines in my project. And this approach is much more efficient and cleaner than traditional callback-based methods for handling asynchronous operations. So that's why I used it, and it improved the overall performance of getting data from that API. So just like a summary of anything you need to remember from the talk for coroutines, it is language and framework specific. So primarily I use it for Kotlin because I'm a Kotlin developer, but you can use it in frameworks like .NET as like async and await. You can also use it in Python, but it's not really like a native Java feature, but it's cooperative for multitasking. So coroutines rely on that basically because it yields control explicitly, and it also has efficiency in input and output operations. So due to the non-blocking nature, it's lightweight, and they don't have like a dedicated stack for each instance of a coroutine, which is quite nice. And you have control over concurrency. You can schedule your coroutines, you can cancel them, you have control of your concurrency structure within your application. Yeah. So now that we've covered coroutines, let's move to virtual threads. So I found this picture and I thought it explained perfectly what virtual threads were. But basically, the only difference between a virtual thread and a platform thread is that virtual threads are not bound to specific operating system threads. They're not bound to specific operating system threads, but both virtual threads and platform threads are instances of the Java lang thread. So basically, how it works is like virtual threads use operating system threads for execution, but they can also free up operating system threads during blocking input and output operations. And they also have shallow call stacks. So like they feel like simple, can typically be used for simple operations like HTTP client calls, or that's basically used. for that, and they're best suited for waiting input and output operations. I do not suggest using it for CPU intensive operations. They're not like designed for like long running CPU intensive tasks, because it can lead to bottlenecks, and then you have a limited number of operating system threads, and then they get saturated with long running intensive tasks, which can lead to lots of problems. Yeah. So it's just a introduction to virtual threads. So why should we use them? So they're ideal for applications with concurrent tasks, often like waiting tasks. So an example would be like if you have server applications handling multiple client requests simultaneously. That's where they would most likely be used. And then also like usage in concurrent tasks. So they best suited for tasks with like significant waiting time, like blocking input and output operations. So for example, applications fetching resources during client server interactions. That would be example of usage in concurrent tasks. Yeah. And then for virtual versus platform threads, so I wouldn't say virtual threads execute code faster than platform threads. They just provide a higher throughput of completion of concurrent tasks. So they can handle more tasks concurrently, rather than like reducing latency. Yeah. So there are many ways to implement virtual threads. I had to look this up. Obviously, you can find it if you go to Oracle's documentation, but you can. The first block is just like a simple start your virtual thread, and then you want it to print hello, and then you wanted to print hello, and then you wait for termination. And then you type like thread.join. But basically what that does is it just ensures the message is printed before the main thread ends. So that's just the basic way to maybe start a virtual thread. And then the second part is when you use a thread builder interface. So basically it just allows creation of threads with common properties. So in that specific section of code, they customizing thread names with thread builder sub interfaces basically. So you can also, so in the example I use thread.virtual, but you can also use thread .platform. So you can also use like normal platform threads as well. But basically that is what's happening in that section of code. So the first one is you can use the builder interface to build a virtual thread. Yeah. And then you can also have multiple threads as well. Like you can also call them specific. So you can say like thread 1, thread 2, and then execute them as you would like to. Yeah. And they also have, similar to Coroutines, a try catch block. So they're trying for the first part, and they're trying to catch the interrupted exception, and then they want to print a trace for if they catch the interrupted exception for that block of code. And then the second type of way to like implement virtual threads is using executors. So basically what executors do is they facilitate the separation of thread management and creation from application logic. So in the specific section of code, we're using a executor service creation. So we use executors.new.virtual thread per task executed to create an executor service. So basically what it does is it will automatically manage the thread's lifecycle efficiently, reducing like manual management. And then with the task execution, you can use executor service.submit runnable, which basically it just means you create and start a new virtual thread for each task, which that's part of the code. Well, it's not part of that code, but that's what you can add. When you want to return a future, it just means you just want tracking. So you want, it allows for tracking and management of the task. And then if you use like I'm not sure what line, but after the executed.submit, there's future.get. So for that function, what it does is it waits for the virtual thread task to complete. So for example, a practical example would be print a message upon completion of the virtual threads task. Yeah, so like that's where you can see underneath it says future.get, and then it says system.out.println task completed. So yeah, so that's how that would work. It's efficient with concurrency. So basically, it will optimize performance in environments with many concurrent tasks, and it reduces the complexity in managing multiple threads. So instead of having multiple threads, you can just have fewer virtual threads to run these concurrent tasks. Yeah. So some of the benefits for using virtual threads, they use less power. So that's why I said efficiency with resources. So for example, or how I would like relate to it is that virtual threads allow you to make more calls or tasks at once without needing more phone lines or system resources. That's another way to think of it. It's easier to write code. So writing code with virtual threads is a bit more straightforward because you can replace any type of traditional threading with virtual threading. So you can go into older code and replace platform threads with virtual threads, which is quite nice. And you don't have to like worry about the complex details of rewriting code. Again, you can handle more tasks at once. So virtual threads lets your program do more things at the same time, just more efficiently. It's better for waiting jobs. So for example, if you think of a loading web page, it can do everything else while it's waiting for that web page to load. Yeah, and then it also, as I mentioned, it works well with older code. So you can add virtual threads to existing code, which makes it really nice and easy to use in that context. So just a summary for virtual threads, for like if you just some things you might need to remember. It's part of the Java platform. I hope I'm correct, but I know that it's a feature for Java 2021. But it's really cool to use. So if you get a chance to use it, please try. Preemptive multitasking. So like virtual threads can be preempted at any point, which can simplify code. It is designed for input-output operations. So it's efficient for like waiting tasks, like input and output operations. So instead of while it's waiting for something, you can do many other tasks in the background as well. Automatic threading. So basically what would happen is the JVM handles the mapping of virtual threads to a smaller number of operation system threads, which just abstracts complexity of having many operation system threads as well, if you can map them. Yeah. And then it just simplifies concurrent programming. It's aimed at making it more easier in Java and more scalable. That's why virtual threads is really nice for Java. So the showdown, which one is better? I don't think there is a which one which is better. It really depends on what you're using. If you are using Kotlin, it makes sense to use coroutines. If you're using Java, it makes sense to use virtual threads for more concurrent tasks than to use platform threads. So it just depends what framework you're working in and what you want those features to do. If it's handling like very heavy things, then instead of using platform threads, you'd use virtual threads in a Java application, and then for Kotlin, you'd use coroutines. Use case. So coroutines are very good at multitasking scenarios, but where virtual threads kind of shine is they are used for greater scalability where platform threads might fail or not increase scalability. So that's the kind of the difference really, where you would like use them. And then the use case is coroutines requires you to kind of have a better understanding of asynchronous programming patterns. So you kind of really need to know what you want to do asynchronously within your application to build the coroutine around that, to implement it properly. You know what I mean? Whereas with like Java, if you've used platform threads before, you can just replace them with virtual threads. Um, and yeah, to simplify the concurrency models in Java already. But yeah, that's just like some of the differences. Both are good for scalability, for input and output operations. Um, Virtual threads seamlessly integrates with the concurrency model, and coroutines seamlessly integrates with the libraries of Jetpack and and well, yeah, the libraries of Jetpack and with Jetpack. So both work really compatible with the languages that they are associated with, um, and they both offer better scalability in either one type of application. So I would say, depending on the type of application you would run, depending on your tech stack, that's how you would choose which one to use. Um, but yeah, I would say, in my opinion, I prefer Kotlin, so I would use coroutines more often. But yeah, it just depends on the developer's preferences and what is needed within that project. Yeah. Um, Thank you for listening to my presentation.
Thank you so much, Jessica, for this amazing and wonderful presentation. So now I just want to we do have some questions. Like over here, someone questioned us: do you use flow with coroutines? What moment was tricky for you when you work with coroutines? Can you answer? This
Okay, so
question is by your slash. Sorry if I mispronounced the name.
I've never used the flow function with coroutines. I'm gonna be honest. Um, so I will definitely look into it and then get back to you. So I also have like a blog. I generally write about like all my experiences. So when I look into it, I will be able to answer that question. But the hardest part that I struggled with quarantines is I've never used it before. So let's start there. Uh, I had to like figure out almost like what it does first before I could really use it. So like I had to figure out like what is asynchronous programming and what is like synchronous programming, just to get an idea of what I would use a quarantine for. Then it was easier to implement for an idea that I had. Um, but other than that, the code is really nice. The syntax is easy. It's quite intuitive. Like the try catch block is like you can see what it like means. The code is so intuitive part. So that's the part I loved about it. But I think it's just because maybe I've never really been exposed to the idea behind quarantines before. So that was the challenge for that specific project. Yeah.
So I think we are good to go. So thank you so much, Jessica, for this amazing and wonderful session. And it was really pleasure having you. Even I really learned a lot of things from you. And that's it. Do you want to say anything to the organizers or audience? Any message or anything?
Sure. Yes. I would like to say thank you to all my mentors that yeah, to all my mentors that helped me preparing for this talk or helped me in any way with my project or like just helping me get ready. Um, for anyone, for to all the audience who joined. I really appreciate your support, and thank you to the organizers for um, seeing my talk as great potential. And yeah, I just like to thank you, Dennis, for hosting me as well. Yeah, and thank you everyone for being here.
Thank you once again. You, it was really pleasure hosting you. Thank you. Thank you.